Hi, in the previous video we talked about how important it is to have a reliable air handling unit and how rooms must be cooled and how rooms must be designed, etc. Now I want to talk a little bit more about the heat exchangers and the way they are controlled, and then probably in a third part we will talk about cooling, heating, and relative humidity. To be able to control the temperature and the humidity, we have to use multiple coils. If you look in this case, this is a heat exchanger, and when the air passes by, it's gaining energy, it's gaining heat. And now you will see this is a cooling heat exchanger, and this cooling heat exchanger, it is cooled by either water or glycol which passes by. So when the air passes by through this heat exchanger, it drops the energy and the air is getting cool. We also can use the heat exchanger to dehumidify the air or remove moisture from the air. That implies running this heat exchanger below the dew point, but I will speak about this in the next video. So if you are cooling too much the air, you then have to use the heater to reheat the air, or if you lose too much moisture from the air, you have to use the humidification system. So let's talk about this in the next video. Now I just want to show you how these heat exchangers are working and how the actuators controls the heating or the cooling agent which passes by through these heat exchangers. This design is slightly questionable. As you'll see, we have a pump which circulates the agent through the heat exchangers, or it could be even a boiler, like a heating boil. If this circuit is very short, it's pointless to have an actuator to close the access of the intermediary cooling or heating agent to the heat exchanger, because we'll have cooling inertia and the chillers could be disturbed, and if you'll have a heater, the boiler can be disturbed. So this system is normally for very long circuits or for circuits that are using multiple heat exchangers, and then yes, you can use actuators because you might want to control different temperatures in different rooms. This is an example for a system where actuators are justified. You can see here one heat exchanger is bluer than the other one. What I tried to represent, one runs cooler below the dew point, we remove moisture from the system. The other one runs above the dew point, it doesn't remove. So see, if you use actuators, you can control the flow through these actuators, and then obviously you can control the capacity of the actuator. There are many other aspects to be considered, but let's keep it simple for now. So I have a pump that it's circulating the cooling agent through individual heat exchangers, and the actuators are modulating, allowing more or less for the glycol or the cold water to pass by through these heat exchangers. So in this case, yes, the actuators are justified, because you have to control individually, independently, two heat exchangers. So if one will close, the other one will run, etc. So just watch this little video and understand, because this is very important. I work for Marks & Spencer, and I found small units using actuators only for one heat exchanger, and the boiler was within 2 meters. So the boiler was overheating all the time because the actuator was closing the loop. So it will be easy to control the temperature by modulating the boiler than by modulating an actuator if you use this boiler to heat only one heat exchanger. Even when you use a chiller, if you use a chiller, the chiller will have its own inertia, will overshoot, because if you are closing the loop and the circuit become very short, the chiller heat exchanger, water heat exchanger, it can ice up. So just remember, anytime you want to use an actuator, make sure the use of it will justify. So choose the appropriate system to use actuators. This is a situation in which the actuator and the valve is justified. This is just a branch of a larger system. And I'll give you an example. Let's say you work in a big building, and that building have many offices, and this specific branch does only one office. We will not stop all boilers because we want to cool down one office. That's why we have this valve. We can restrict the heating agent, and the heating agent will not bypass through the heat exchanger, and then we can ventilate the room through this heat exchanger, and this room will cool down. So as you'll see in this picture, the heating agent, which can be water or glycol or steam, whatever, is passing by via the bypass balancing valve. You know, if you use a steam, it's a little bit different. I will not explain this in this situation. You'll also observe that I have a condensed water and a drip tray underneath this system. Maybe it's not a usual thing, but sometime we're using heat exchangers that have the capability to heat and to cool the premises. So this heat exchanger will receive either hot or cold intermediary cooling or heating agent, and this is a situation in which I'm going to use a drip tray and condensed water, even if you see that this system in this moment it is ready to run on heating mode. In this example, you will see that the system is prepared to run on a cooling mode. Let's put it this way, it is a summer, we run the chiller, we don't need the heating, so the pipe is cold, and again, this is just a branch of a larger installation, so the actuator turned off the valve and restrict the glycol to pass by to the heat exchanger, so the premise is already cool, and we do not need to cool the premises. So this is a cooling control capacity of the local area, but the chiller is keeping the glycol cold. Looking into this type of system, you'll observe that the heating agent is not reaching the heat exchanger because the actuator closed the two-way valve. So the heating agent doesn't reach the heat exchanger. Now the actuator is turning on the valve. Once that happens, the heating agent is passing by through the heat exchanger, and the heat exchanger starts to get warm. But you see, it's not very warm because this is controlled, the flow it is controlled by the actuator, and the actuator is controlled by the PLC, and the PLC gets instruction from a thermostat. In case we need more heat because the office is too hot, we allow more heating agent to pass by through the heat exchanger, and the heat exchanger will have its temperature increase on a larger area, and then we will heat the premises. It is simple as such. The same happens with the cooling capacity control. We allow the cooling agent, the glycol or the water, to pass by to the heat exchanger, and the heat exchanger will start getting cold. In this case, the heat exchanger is running above the dew point. Can't you see the drip tray doesn't have any water inside because the heating agent is not very cold to cool enough the heat exchanger. Now the heat exchanger got cooler because the glycol is cooler, and the actuator allowed the two-way valve to open more, and then more glycol will pass by to the heat exchanger. And you'll see now the water will lose the moisture, and the condense will go down onto the drip tray and will be eliminated to the condensate water pipe. This is simple. So this is the way we cool the premises. See, the heat exchanger have the capability to take cooling agent, either water or glycol, or heating agent, which can be glycol or water. Steam demand a different type of installation, and I explained this in other video. This is very interesting thing. Sometimes the valves, look at the actuator, the valves are freezing. That little shaft is blocking and the valve remains open. So your office will freeze even if your controller will tell you that the heating has been turned off. There's nothing you can do about. And until you repair that little shaft to stay in this position and to close the valve, you cannot divert the entire quantity of cooling agent. So the cooling agent will constantly pass through the heat exchanger, and then you have to stop the fan probably. But if you move it through a very cold heat exchanger, you will always have a cooling process in progress. Thank you very much watching this video. I hope you found some bits and pieces that you can use. Remember, a heat exchanger without like heating agent passing by through it is nothing. This is something about how you can control the relative humidity and the moisture.